It's the 25th of March 2020. I'm Vic Chevalon, BCM Resources Consultant. I'm working with Rick Redfern, VP of Exploration for BCM, on the Thompson Knolls 3D modeling and exploration planning. This is the BCM claim block on a topo base, 7.5 minute topo base. The squares are 1 square mile. And the claims cover about 5 square miles, about 2 miles south of one of the main highways, US 50, that crosses the Great Basin. Access is excellent year-round. The high ground is all limestone, and the low ground is all valley fill gravel cover rocks. The properties in the Kings Canyon Carlin type gold exploration area. The black squares are historical Carlin type drill holes. We don't have all the data for the holes. The yellow holes are Carlin holes too, but they had either marble or copper showings in them that might relate to the Porphyry system that was BCM discovered in TK 18-1 out in the valley beneath 181 meters of valley fill gravel. BCM's original target was the Bingham Canyon type deposit beneath gravels, and as projected on coincident mag high and gravity low anomalies that BCM identified, hole 18-1 cut into a porphyry copper moly gold system. The claims were originally staked on a magnetic high anomaly on the map, state, the Utah state map. This is a satellite base map with a 1 kilometer grid. For scale, you can see TK 18-1 was out in the valley gravels, well away, about 0.8 of a mile away from the closest limestone outcrops in the hills surround the hole on 3 sides. Under Rick's direction, BCM conducted a ground mag survey and identified a distinctive magnetic high out in the gravels. This was followed up by a gravity survey, and it defines a nice gravity low coincident with the mag high. For scale, this is the ore shell of the Bingham Canyon deposit. So there's plenty of room out here for a major discovery. TK 18-1 was spotted in the center of the mag high and drilled 181 meters of gravel, and then hit a mineralized porphyry system, composite stock. We'll look at it in 3D. Rick drew cross sections centered on the drill holes, and we'll look at those in 3D. And these sections is where we started with the modeling, with the 3D modeling, to display what we think the hole hit and what the exploration plan would be to offset this hole. Actually complete the hole, because it was lost at 348 meters due to drilling equipment and driller problems in a fault. The fault was within the intrusives that were cut in the hole. Now we'll turn on the lithologic model. They were building from the cross sections, and the geophysics. Hole TK18 drilled through that 181 meters of gravel and then intersected bedrock contact shown in brown. The pink rocks are a quartz latite porphyry stock. The top of the stock is modeled as flat because it looks like an erosional contact, and the stock is weathered. All the sulfides in the stock most of them have been converted to iron oxides and copper oxides toward the lower portion of the hole. Also hit this interior, toward the end of the hole, we hit this interior nested younger quartz monzonite porphyry, and this is the mineralization and the veining and the alteration picks up at depth. We'll look at this in the hole. First, we'll turn off the cross sections, and we'll turn off the topography satellite image so that we can get a good feel for the. Here's the magnetic high the hole was centered in. We'll turn that off and just look at the model with all the gravel stripped off of it. We'll turn it around. The blue planes are faults. We know they're in there. We don't know their orientations or their throw. We've shown a major linear in the gravels with presume that's a fault, and we interpret it to have a east side down throw on it. You can see the gravel is blank in this view. That brown plane is the bedrock surface with the intrusives. Nested intrusive is a composite stock below. We'll look at the model in cross section now to get a better feel for the geology and the geometry of what was hit. The grid, both grids are both grids are a kilometer square for scale. The lower one is 1,000 feet deep. Just to show the geometry of what we're looking at. We'll turn on the assays on the hole, moly and copper, and zoom in. This is a histogram. The blue is moly values, all geochemical values. The red is copper values, again all geochemical values. The high in the red is 649 ppm. Gold is not shown, but gold is present in geochemical amounts pretty much all the way down the hole. The thing that's interesting in this view is that the mineralization, copper and moly mineralization, started right at the bedrock interface and gradually increased down the hole, especially in the last portions of the hole. Where there's a good gradient, increasing copper gradient. The other thing that's interesting, I went back and logged the core again and did a vein count, and that vein count is, these are stockwork veins typical of porphyry deposits. The vein count is shown here in this black histogram, and you can see a good correlation of vein count and copper mineralization. As you get down toward the bottom of the hole, what happens is a lot of the stockwork veining is quartz, copper oxide and minerals, and also as you get lower in the hole, down in this quartz monzonite, you start picking up disseminated copper oxide minerals. This gradient is important because TK18-1 was lost in a fault due to driller problems and their equipment failure at the bottom of the hole. And what we're proposing is, in phase 1 exploration, is to complete this hole. The hole was only drilled about 50% of its planned depth. So we want to double the length of the hole down to about 700 meters or so, and see what this copper and moly does at depth. We'll look at the details of the rocks that we encountered, and also the geochemistry later in the static part of the presentation. And one thing we did when I relogged the hole was relog the alteration in the hole. And these are the alteration contacts that you can, the upper one is between propylitic alteration uphole in the bedrock and phyllic alteration downhole from this contact. There's also potassic alteration in the bottom of the hole, and it's in disequilibrium. In other words, it cuts the phyllic alteration, and it also is cut by the phyllic alteration. We'll see this in the drill core pictures, talking about it a little bit more, but this is important because this alteration gradient is just what you see in the hole, is just what you see as you approach the center of a porphyry system. You go from lower grade alteration, the propylitic uphole, to higher grade alteration, the phyllic and potassic alteration down the hole, with increasing metal grades. The name of the game in the porphyry exploration business is to understand the alteration in detail, so that you can get a feel for the zoning of the alteration, and that zoning that's mappable will take you right into the center of the deposit where the copper grades are the highest. This is our, because of this potassic alteration that we see in the very bottom of TK18, I projected the another contact alteration zone that's potassic alteration, shown in the yellow, and the potassic alteration would be most abundant below this contact. The significance of this is that that's where the copper generally really picks up, and the copper is actually in most porphyries is most abundant in the basal phyllic and the upper potassic alteration, and that's what I've tried to show here with this red. This is our copper target. So we feel that we're just, the geology is telling us that we're just above this this shell. Now on this view, it's important too that we don't know where we are in this stock laterally. We know we're in the stock, but we don't know whether we're on the edge of the stock, in the center of the stock. We just don't know at this stage. There needs to be a lot more drilling, and that's what we're proposing in the exploration program. So I think what we'll do is jump out of the cross-section view of the model and just look at the model in 3D. Zoom out a little bit, and you get a feel for the concept, the target that we're looking at, the amount of space that we have. Again, this offset of the alteration, and the copper zone, projected copper zone, and the intrusive and so on is speculative at this time. We just need to do a lot more drilling. I'll give you a top view here that shows what we're looking at in terms of the lateral extent of what we think is a target. The stock shape conforms to what the geophysics is trying to tell us, we think. And so it's quite a large target, and We'll look at it in section again and rotate it around so you get a feel. And you can pull this section out to see the north side of the system. So this is the target that we're looking at. And to give you an idea of the exploration we're proposing, this is the proposed holes. I'll turn these on. Can't find them in the list here. It's a big model. Here they are. These are 2,000-foot holes. The first thing we're going to do is finish hole 18-1, and then we need to drill fences across the system, probably north, south, and east, west. We're thinking about 10 holes, and by doing this type of mapping and modeling in 3D as we drill, we should be able to draw real cross sections through the alteration and so on, and use these the mapping that we do in the drill holes to define the alteration contact shapes and march right into the heart of the system. We're looking for the gradation between the phyllic and the potassic alteration, which should be the highest grade portion of the system, highest grade copper portion of the system. Now, one thing that I didn't mention that's quite important from an exploration view is that in 2019 we obtained a lead isotope age date on the intrusive in TK18. It turns out to be much older than Bingham Canyon. It's 62 million years, which places it in Laramide age, which is entirely unusual and unique in this part of the Great Basin, the Eastern Great Basin. This is Laramide porphyries. You'll see a map in the static part of the presentation. Include most of the porphyries in Arizona, New Mexico, including the gigantic resolution porphyry that's being developed by Rio Tinto now at Safford, Arizona. It also includes Butte, one of the biggest mines in the U.S. And Butte is copper and moly deposit, mostly noted for its copper. This is Laramide age is quite significant because there's a lot of information on the exploration characteristics of Laramide porphyries, and Laramide porphyries account for most of the copper discoveries and production in the U.S. in the last 50 years. This is a alteration zoning diagram for Laramide porphyries that was derived by Lowell and Gilbert in 1970, and I just brought this into the model to show roughly where we are in this model. This alteration zoning model is really important. It's been used around the world successfully to find and develop porphyry coppers. It's just pretty much industry standard model, and you can see the bottom of our hole TK18 is basically right at the top of the phyllic zone, and we're drilling toward the potassic zone and our interpretation of what ore might look like. Now, I just imported this model a couple days ago. We did the modeling, our own 3D modeling based on the core logging and so on, last month. So this is kind of an independent view of what we did before we imported this thing, and how it matches the industry standard model. So we're quite enthused about this. We'll take one more look without the cross sections. And then take a look at it from above to get a feel for the drill hole spacing. You'll see in the static presentation that most of the roads for these drill holes are already permitted. It's drill ready project. And we don't know really exactly where the holes are going to go at this stage. It just depends on what we find in these fences of holes. And that also applies to the depth of the hole. So that's it in an expanded nutshell. And now we'll get back to the static presentation.